This is assignment 3. Assignment 3 asks us to implement a set of C functions for a binary tree search. So the program will have functions for inserting nodes, searching, counting nodes, and determining the tree height. The program is supposed to ask the user to insert an integer and print out all the numbers inserted into the tree and then sort them out from smallest to largest. It also needs to print the tree height and the total nodes in the tree. So in order to begin, we need to make a header file, which we call bst.h. Here we have aliases for the item, the node, and the pointer to the node. We also need a struct to define items, which are the contents of the BST nodes. The tree node struct has the message item, which is the data, the link for the left subtree and the right subtree. So these are pointers to the BST node. So in our header file, we also declare our function prototypes. So here we have a list of private and public functions. So private variables are only accessible to the bst.c file. So the root is the root of the BST, and the null item will indicate that a leaf was reached. And finally, we can list our function prototypes that we'll be using for the other files in the project, which are here. So in our bst.c file, we need to add our function. These are the implementations for the functions. So the first function needs to create a node. This is the new function. So it creates a new BST node by passing an item. This gives us a pointer to the node we create and then stores pnew to the message. And we can store the item in there. So now we can assign pnew to the left and right. Then we return the pointer to the new node we created. So this here initializes the BST. So everything is empty and it creates a new root and initializes the BST. For the BST function, RC is our string. So it's a recursive function. So if H is null, it says to return null. Means we do a search. If we find nothing, then we can stop searching. That's why we were returning a null item, because nothing was found. So now we need to go left or right. So here we're comparing two pointers to two strings to check whether or not they're equal. So if one is greater or less than the other, determines if we go left or right in the tree. And if RC is 0, then we found it, and then we return the item. So for our recursive subcalls, if RC is less than 0, then we can go left, else to go right. For the insert function, it inserts a pointer and tells it to either go left or right, then uses a recursive call for traversing the tree to get a leaf. For the BST print function, this is code that prints the BST in sorted order using in-order traversal. So this will sort the integer values from smallest to greatest, and in-order traversal patterns is left, then center, and then right. So to make the height function, we need to look at the left and right side. So if the item is null, then it means we've reached the leaf. Then we can check the left and the right and see which one is greater. So if the left is greater than the right, we know that it's the greatest one. Else, it's the right one is the greater one. For the count function, we need to count the left and right branches, and counting the total by adding the nodes to the total. And then for the get return, it just returns a pointer to the root of the BST. And finally, we can go into our main file, which also calls the initializing function, and that initializes the BST. So we use the printf function and ask the user to enter the number of nodes they want to use and put into the BST. Then that lets the user enter the values line by line, which is done using a for loop, and then calls the insert function each time to insert the integer and repeats itself until the number that the user entered is done when asking for a number of nodes to insert, and stops when that number is met. So after that, we call the print function perform the task in sorting the tree from smallest to greatest, then prints the number of nodes in the tree, calling out the count nodes function using the root values. And the same way for the height, we print the height of the tree by calling the height function and using the root values. So we can incorporate the search function and search for the last inserted item. And then we can run it. So when we run it, we can insert 5 nodes, for example. So the program outputs the integer values from smallest to greatest. It tells the user what the height is, the number of nodes, and the last item put into the tree. So the program works, and this is assignment 3.